Are you ready to listen the class, my dear children? Right. See, first point, geometric progression. It's a short form is GP. Okay, my dear children. Capital letter G dot capital letter P dot. In this exercise, the problems are based on geometric progression. Okay, my children. That is why we discuss definition of geometric progression. A sequence A1, comma A2, comma A3, comma and so on, AN, comma and so on is called geometric sequence or geometric progression if each term is non-zero and AK plus 1 by AK is equal to R, a constant, for K greater than or equal to 1. Understood this definition, my children? It means the ratio of two consecutive terms. The ratio of two consecutive terms always a constant. The ratio of two consecutive terms in the sequence is a constant. Then the sequence is called geometric sequence or geometric progression. Okay, my children, is this point clear? Right. By letting A1 is equal to A, in this sequence, if it is a geometric progression, if you consider the first term A1 is equal to A, we obtain a geometric progression A, comma AR, AR cube and so on, AR to the power of n minus 1 and so on, where A is called the first term and R is called the common ratio of the geometric progression. This is the general form of geometric progression. Okay, remember this one. In solving the problems related to geometric progression, you have to remember this general form of geometric progression, where A denotes the first term and R denotes the common ratio of the geometric progression. Is it point clear, my children? Right. Now come to the next point, second point. We use the following notations. A, small letter A is equal to the first term, small letter R, the common ratio, small letter L, last term, small letter n, the numbers of terms, Sn, the sum of the first n terms. Okay, my dear children, remember all these notations throughout this exercise 9.2. Okay, my dear children, right. Now come to the next point, that is third point, general term of a GP, general term of a geometric progression. Okay, my children, let us consider a GP, geometric progression, with the first term A and common ratio R. Okay, my children, in the geometric progression, let A be the first term and common ratio is small letter R. Then the general term of geometric progression is equal to AN. AN denotes general term of the geometric progression, that is equal to A into R to the power of n minus 1. Okay, my children, this is called general term of geometric progression. Okay, my children, remember this point as a formula. Right, now come to the next point, geometric series. Same as arithmetic series. AR square, AR cube and so on, AR power n minus 1. All these terms form geometric sequence, geometric progression. Yes or no, my children? If we add all these terms, then we get a geometric series. The series A plus AR square plus AR cube plus and so on plus AR power n minus 1 plus and so on is called geometric series. Okay, my children. A small difference. In the previous exercise, we have discussed arithmetic progressions, here geometric progression. That is only the difference. Okay, my children. Please learn all these concepts well. You have to apply all these concepts to solve the sums in the exercise. Okay, my children. Right. Now come to the point number 5. Sum to n terms of a geometric progression. In the case of arithmetic progression, we have discussed the sum of the first n terms of arithmetic progression. Yes or no, my children? Right. Here also we are finding the sum of the first n terms of a geometric progression. Let a small letter a be the first term and small letter r be the common ratio of a geometric progression. Then sum to the first n terms of a geometric progression is denoted by Sn. Therefore, Sn is equal to a plus ar square plus and so on a r power n minus 1. This expression gives sum of the first n terms of a geometric progression. Here there are two cases arises. Case 1, if r is equal to 1, if the common ratio is 1, substitute r is equal to 1 in this expression. What we get? First term is a, second term is also a, third term is also a, and so on. Last term is also a. How many terms are there? N terms. Okay, my children. So a plus and so on, n terms, n times. So na. Okay, my children. Right. Case 2, if r is not equal to 1, means the common ratio less than not equal to 1, then r may be greater than 1 or less than 1. If r is greater than 1, then sum of the first n terms of the geometric progression is Sn, that is equal to a into r power n minus 1 by r minus 1. Remember this formula, my children, if r is greater than 1. If the common ratio is less than 1, then we use this formula to find the sum of the first n terms of a geometric progression. Sn is equal to a into 1 minus r power n by 1 minus r. Okay, my children, remember all these points as formulae. Okay, my children, right. In the previous exercise, we have discussed arithmetic mean. Yes or no, my children? Right. In this exercise, we are going to discuss geometric mean. Geometric mean is denoted by capital letter G dot capital letter M. Geometric mean. The geometric mean of two numbers A and B is equal to square root of AB. Square root of AB. This number denotes geometric mean of two numbers A and B. Remember this point. What is the arithmetic mean of the two numbers A and B? Yes, A plus B by 2. Do you remember that point, my children? Right. Given any two positive numbers A and B, we can insert as many numbers as we like between them to make the resulting sequence in a GP. As in this case of geometric progression, here also we can insert as many numbers as we like between the two numbers A and B so that the resulting sequence is a geometric progression. Okay, my children. Right. Now come to this next point. Let G1, G2, G3, and so on, Gn be n numbers between positive numbers A and B such that A, G1, G2, G3, and so on, Gn, B is a GP. Okay, my children. We insert numbers between A and B. Then Gn is equal to A into B by A whole power n by n plus 1 to get the first number. Keep here n is equal to 1. Then we get the first number. Understood this point, my children? We inserted n numbers between A and B so that the resulting sequence is a geometric progression. Then we get the numbers which were inserted between A and B by using this formula. Understood this point, my children? Right. The case of arithmetic progression also we have found. Do you remember that formula, my children? Right. Similarly, here also we can find the numbers which were inserted between A and B so that the resulting sequence is a geometric progression. So remember this formula. Okay, my children? Right. Now come to the last point. Relationship between arithmetic mean and geometric mean. In this point, we are going to discuss the relation between arithmetic mean and geometric mean of two numbers. Okay, my children. Right. Let capital letter A and capital letter G be arithmetic mean and geometric mean of two given positive real numbers A and B respectively. Let us assume that capital letter A is a arithmetic mean of two numbers A and B, and capital letter G denotes geometric mean of the two numbers A and B. Then you know that capital letter A is equal to A plus B by 2, arithmetic mean. And then geometric mean of these two numbers is square root of A and B. Yes or no, my children? Then we obtain the relation A greater than or equal to G. This is a relation, which is a relationship between arithmetic mean and geometric mean of two numbers A and B. Okay, my children, understood? Right. Hello, my dear children. Now come to the problems. Exercise 9.3 sums. Let us start exercise 9.3 sums. The concepts of exercise 9.3 were completed. Okay, my children. Right. See page number 192. Page number 192. See the first question. Question number 1. Find the 20th and nth terms of the geometric progression 5 by 2, comma 5 by 4, comma 5 by 8, and so on. Okay, my children, understood this question? Right. Here a geometric progression is given, that is 5 by 2 given geometric progression. 5 by 2, 5 by 4, 5 by 8, and so on. In this geometric progression, what is the first term? Yes, 5 by 2. So first term, A is equal to 5 by 2. Okay, my children, understood this step? Right. Next, let us find common ratio. Common ratio, that is denoted by small letter r. Okay, my children. How do you find the common ratio of a geometric progression? Second term by first term. Okay, my children. 5 by 4 by 5 by 2. Or third term by second term. Or fourth term by third term, and so on. Okay, my children. Right. Then what we get to? 2 by 4. That is equal to 1 by 2. Understood this step, my children? So this is the common ratio. We found first term of the geometric progression and common ratio of the geometric progression. Then we can find 20th term. What is the general term of a geometric progression? Nth term. Tn or An. You can denote it Tn, means nth term, or An, nth term. What is the formula? A into r to the power of n minus 1. Do you remember this formula, my children? Nth term of a geometric progression. Right. What is A here? 5 by 2. So 20th term. So 20th term, that is T20 or A20. A20 is equal to, what is A here? 5 by 2 into what is R here? 1 by 2 whole to the power of, what is N here? 20 minus 1. Understood this step, my children? Right. That is equal to 5 by 2 into 1 by 2 whole to the power of 19. Yes or no, my children? Understood that step? Right. That is equal to 5 by 2 into 1 by 2 to the power of 19. Okay, my children? Understood this step? Right. By simplifying these two numbers, what will you get to? 5 by 2 to the power of 20. This is the 20th term of the. Understood the step, my children? Right. Now we have to find nth term. Nth term of the nth term of the geometric progression, that is Tn or An. What is a formula? A into r to the power of n minus 1. Okay, my children. So, a, what is a here? 5 by 2 into what is r here? 1 by 2 whole to the power of n minus 1. Understood this step, my children? Right. Then what you get? 5 by 2 into 1 by 2 to the power of n minus 1. Understood this step, my children? A by b whole power n is equal to a by a power n by b power n. We used here laws of exponents. Okay, my children? Right. That is equal to, by simplifying these two numbers, what will you get? 5 divided by 2 to the power of n. Again, here we used laws of exponents, a power m into a power n, a power m plus n. Okay, my children, directly I wrote the resultant value. Yes, sir, my children, okay, understood this step? Right. Now come to the next question, that is question number 2. Second question. Find the 12th term of a geometric progression whose 8th term is 192 and the common ratio is 2. Understood this question, my children? Yes, we have to find the 12th term of the geometric progression. Here 8th term of the geometric progression and common ratio were given. Okay, my children? Right. Now come to the solution part. Let us write the given data. Given 8th term, 8th term of a geometric progression, that is T8, that is equal to A8. What is a okay, my children? This implies, how do you denote A8 or 8th term? A r to the power of 7 is equal to 192. Okay, my children, where a is the first term of the geometric progression and the common ratio is r. Okay, my children, right. That is consider this is equation 1. Given common ratio of the geometric progression, that is r is equal to 2. In the question itself, it is given. The common ratio of geometric progression is 2. Now let us substitute r is equal to 2 in the equation 1. Substitute r is equal to 2 in the equation 1. Then we get a 2 power 7 is equal to 192. Understood this step, my children? Right. This implies a into what is the value of 2 power 7? 2 into 2 into 2 into 2 into 1, 2, 3, 4, 5, 6, 7. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, 32 2s are 64, 62 2s are 128. So 128 is equal to 192. Okay, my children, understood this step? Right. 128. This implies A is equal to 192 by 128. Okay, my children, understood this step? Then what will you get by simplifying these two numbers? Simplify by 4 table, 4 3 times, 4 4 times, 4 8 times, 4 3 times and 4 2 times. Okay, my children. 16 4 times, 16 3 times, 16 table, 16 3 times, 16 2 times. That is 3 by 2. Therefore, A is equal to 3 by 2. This is the first term of the geometric progression. We got first term of the geometric progression. But actually, what should we find? 12th term of the geometric progression. Therefore, 12th term 12th term of the geometric progression, that is T12 or A12, is equal to A r to the power of 11. Okay, my children? Right. That is equal to, what is A here? 3 by 2 into, what is R here? 2. So 2 power 11. Okay, my children? Right. Now let us simplify. 3 into 2 power 10. 3 into 2 power 10. Then what is the value of 2 power 10? 1024. 3 into 1024. Okay, my children. Understood this step? Now let us multiply these two numbers. 3 into 1024. What will you get? 3072. This is the 12th term of the geometric progression. Understood, my children? Right. Now come to the next question. That is third question. Question number 3. The 5th, 8th and 11th terms of a geometric progression are P, Q and S respectively. Show that Q square is equal to PS. Understood this question, my children? Right. 5th term of the geometric progression is P. 8th term of the geometric progression is Q. And 11th term of the geometric progression is S. Then we have to show that Q square is equal to PS. Okay, my children? Right. Now, let us consider A be the first term and small letter R be the common ratio of the geometric progression. Okay, my children? Let A be the first term. Let A be the first term and small letter R be the common ratio of the geometric progression. Okay, my children. What is given? 5th term of the geometric progression is P. Given 5th term of the geometric progression, that is T8. What is a 5th term? P. Okay, my children. How do you write 8th term of the geometric progression? A r power 7. Okay, my children. That is P. Let us consider this is equation 1. Okay, my children. Understood this step? Right. Now 8th term. Oh, sorry, 5th term. Here 5th term T5. So A r power 4. R power 4. Now 8th term. 8th term of the geometric progression. How do you denote it? T8. 8th term is T8. What is 8th term of the geometric progression? Q. Okay, my children. This implies, how do you write 8th term of the geometric progression? A r power 7. Yes or no, my children? Is equal to Q. Consider this result as equation 2. Okay, my children. Now come to the 11th term. 11th term of the geometric progression. T11 is equal to S. How do you write 11th term of the geometric progression? A r power 10. S or no, my children? Is equal to S. Consider this result as equation 3. Now we have to prove that Q square is equal to PS. Let us take RHS part of this equation. What is RHS part of this equation? PS. Okay, my children. RHS PS is equal to, what is the value of P here? A r power 4. Yes or no, my children? So A r power 4 into what is S here? A r power 10. Yes or no, my children? Right. That is equal to A square into r to the power of 14. Yes or no, my children? Then how do you write this one? A square r to the power of 14. A r power 7 whole square. Can we write it or not? By using the laws of exponents, we can write this part as a r power 7 whole square. Yes or no, my children? Right. This is nothing but q. So q square. This is LHS. Therefore, LHS is equal to RHS. Hence proved. Understood, my children? Right. Now come to the next question, that is the fourth question. The fourth term of a geometric progression is square of its second term. And the first term is -3. Determine its seventh term. Understood this question, my children? Yes. The first term of the geometric progression is given, and a condition also given. Fourth term of the geometric progression is equal to square of the second term. Okay, my children, with the help of these conditions, we find the common ratio, and after that we find the seventh term. Okay, my children, right. Come to the solution part. Let us consider, let A be the first term, and small letter r be the common ratio of a geometric progression. First, let us assume that A be the first term and small letter r be the common ratio of the geometric progression. Now, what is given here? First term. Given first term. First term of the geometric progression, that is A, is equal to -3. It is given. Now, we have to find common ratio of the geometric progression, but it is not given directly. But a clue, a hint is given, a condition is given. With the help of this hint, with the help of this clue, we find the common ratio of the geometric progression. Given fourth term of the GP, fourth term of the GP is equal to square of the second term. Square of the second term. This is a given condition. This is a clue. This is a hint for us to find the common ratio of the geometric progression. Okay, my children. Right. How do you denote this? How do you write T4? Fourth term is equal to second term whole square. Yes or no, my children? Right. How do you find the fourth term? A r cube is equal to A r. Yes or no, my children? Whole square. First term is A and common ratio is r. So fourth term is equal to A r power n minus 1. 4 minus 1, 3. So A r cube is equal to A r whole square. Okay, my children, understood this step? Right. This is equal to A r cube is equal to A square r square. Okay, my children, by using the laws of exponents, I wrote this step. Understood this step, my children? Right. This implies, what is A value here? -3. Let us substitute. -3 into r cube is equal to minus 3 whole square into r square, because a is equal to minus 3. We substituted a is equal to minus 3 in this step. We got this step. Understood this step, my children? Right. This implies minus 3 r cube is equal to 9 r square. Yes or no, my children? Right. Now let us transpose the r square to LHS. Then it becomes r cube by r square is equal to 9 by minus 3. We transpose minus 3 to RHS. It becomes minus 3 by minus 3. Okay, my children, understood this step? Right. This implies r cube by r square. What will get? R is equal to 3 1 times, 3 3 times. So minus 3. So the common ratio of the geometric progression is minus 3. We got common ratio of the geometric progression. Then we have to find seventh term of the geometric progression. Therefore, seventh term of the geometric progression, that is T7 a r power 6. Yes or no, my children? Right. That is equal to, what is a here? Minus 3 into, what is r here? Minus 3 whole power 6. What will get here? Minus 3 whole power 7. Yes or no, my children? Find the value of minus 3 whole power 7. Minus 3 into, minus 3 into, minus 3 into, minus 3 into, and so on. What will get? 2187. 2187. Understood, my children? This is the seventh term of the geometric progression. Okay, my children? Right. Now come to the next question, that is fifth question. In this fifth question, there are 3 parts, but here I am explaining only first part of this question. Please try the remaining 2 parts of this question. Okay, my children, will you try the remaining 2 parts of this question by yourself, my children? Yes. If you have any doubts, ask your doubts and get your doubts clarified by following the same procedure as we are following for this question. Okay, my children? Right. Which term of the sequence 2, comma 2 root 2, comma 4, comma and so on is 128? Understood this question, my children? Here we have to find the position of this number, position of that number in this sequence. Right. Now let us write the given sequence. Given sequence. Two comma 2 root 2 comma 4 comma and so on. Okay, my children. If you observe this sequence, it is a geometric progression. Yes, sir, my children. Here a is equal to first term. Here first term a is equal to 2 and the common ratio. You have to identify whether this given sequence is a arithmetic progression or geometric progression. Since this entire exercise is based on the geometric progression, directly I am telling this sequence is a geometric progression. But in the examination, you have to examine, you have to verify whether the given sequence is a arithmetic progression or geometric progression. How do you find the common ratio? 2 root 2 second term by first term, children, or third term by second term. Right. So 2 root 2 by 2. What you get here? 2 root 2. Therefore, r is equal to root 2. The common ratio of the geometric progression is root 2. We got a value, that is 2, and the common ratio is root 2. And what is given? The nth term of this sequence is 128. Okay, my children, let us consider this is the nth term of the geometric progression. Let Tn is equal to 128. Nth term of this geometric progression is 128. So Tn, how do you write the nth term of the geometric progression? A r power n minus 1 is equal to 128. Okay, my children. Right. Now let us substitute a value and r value. What is a here? 2 into r value. What is r? Root 2 whole power n minus 1 is equal to 128. Okay, my children. Understood this step? Right. This can be written as root 2 whole square into root 2 whole power n minus 1. Yes or no, my children? And let us write to 128 as prime factors. 264 times, 232 times, 216 times, 28 times, 24 times, 22 times. 1, 2, 3, 4, 5, 6, 7. 2 power 7. 128 can be written as 2 power 7. 1, 2, 3, 4, 5, 6, 7. Okay, my children, understood this step? Right. Here, this can be written as a power m into a power n, a power m plus n. Yes or no, my children? So, loss of exponents. We use loss of exponents. So, n minus 2 plus n minus 1 is equal. This can be written as root 2 whole square whole power 7. Can we write it or not, my children? Root 2 is written as root 2 whole square and whole power 7. Understood this statement, children? Right. This implies we get root 2 whole power n plus 1. By simplifying these three numbers, we get to n plus 1. Understood this part, my children? Right. Root 2 whole power 14. A power m whole power n. Loss of exponents. Understood this step, my children? Right. This implies here bases are equal. Root 2, root 2. So we equate the exponents. So n plus 1 is equal to 14. Now let us solve this equation for find the value of n. So n is equal to 14 minus 1. That is equal to 13. So 13th term of this geometric progression, 13th term of this sequence is 128. Therefore, 13th term of the sequence of the given sequence is 128. Understood, my children? Right. Here I am not explaining the remaining two parts of this question. Please try yourself. If you have any doubts, ask your doubts and get your doubts clarified. So follow the same steps to find the position of the given number in the sequence. Okay, my children? Right. Now come to the next question, that is question number 6. Question number 6. Sixth question. For what values of x, the numbers minus 2 by 7, comma x, comma minus 7 by 2 are in GP? Understood this question, my children? Right. Here these three numbers are given. They are in a geometric progression. We know that three numbers A, B and C are in geometric progression. That B square is equal to AC. Yes or no, my children? So we use that result here. First, let us write the given data. Given minus 2 by 7, comma x, comma minus 7 by 2 are in geometric progression. Okay, my children. We know that three numbers A, B and C are in geometric progression. This implies B square is equal to AC. This condition will be satisfied by the three numbers A, B and C if they are in a geometric progression. Okay, my children, let us consider this is A, this is B and this is C. Okay, my children, right. So x square is equal to what is a minus 2 by 7 into what is a C here, third number, minus 7 by 2. Understood this step, my children? This implies x square is equal to here 2 gets cancelled, 7 gets cancelled, minus into minus plus 1. Understood this statement, children? Right. Then x is equal to plus or minus the square root of 1. Understood this statement, children? Right. This implies x is equal to plus or minus 1. Okay, my children? Right. Now come to the next question, that is question number 7. Find. Okay, my children, understood the concepts of exercise 9.3 and sums in the exercise. Have you understood? Yes. Only Catherine responded. What about other children? Yes, Manish also responded. Only Manish and Samuel also responded. Esther, yes, Rexlin also. Yes, my dear children. Two more sums are there in this video. Two more sums. Question number 7 and question number 11. I will post this video in the Google Classroom. Please watch the video completely and write your classwork notes. Okay, my dear children. Now the time is 4 past 17 minutes. 4 past 17 minutes. Now you can leave the meeting. My dear children, take rest. Take care of your health. Stay at home. Stay safe and sanitize your hands frequently and maintain social distance of 2 meters away from others and write your classwork notes. Thank you, my dear children. Thank you all. Thank you.